charts are new charts that we just had made, and we're going to be sending them to the 3rd grade classes and the 4th grade classes and the 5th grade classes. But what I wanted to do is I wanted to make a video of how teachers should use these. So are you guys willing to help me make that video?
Yes.
So I want you to take a look at the multiplication chart. And we are going to be talking about patterns. Patterns. Can you think about that word patterns? And will you talk to a person next to you and tell them what you think I'm talking about when I say patterns?
Like something that repeats something
All right, Ice here. I heard some really good things. One of the things I heard from several people is that you said it repeats over and over and over again. Yeah? Anybody else say that? I heard that from at least 4 people. Did anyone use the word predictable? Or something like, I know what's going to be next. Anybody talk about that? So in a pattern has 2 things that must be true. One, it has something about it that repeats over and over and over and over again. The second thing is that it's predictable. That even if you don't write what's next in the pattern, I can figure it out because there's a pattern. So what I want you to do is take a look at this multiplication chart. I want you to look for as many patterns as you can see on this chart. Thumbs up if you have at least 2 patterns. Will you take about 30 seconds to talk to your partner and practice what you're going to tell me when I talk? Woo! Did I hear a lot of good ones?
So I noticed that the 3 and 6 equals 9, and then 9 plus 3 equals 12, and it keeps making the same equation of the number.
Ooh, so what's the pattern?
Plus 3.
And then what happens to get to the 9?
We have to do 3 plus 6.
And then how do I get to the 12?
3 plus 9.
Are you seeing a pattern?
Yeah.
So what would happen when I get all the way here to the 30?
33. You would go back.
Because you're using Grace's pattern, you added 3 more?
Yeah.
Ooh, that means it's predictable. There's a pattern. You found another one. What now is being brought into the room is people want to look at just the ones that are in gray.
Yeah, exactly.
My question to you is, I want you not to say it out, think about it. What's so special about these that they're in gray on this poster? Why are they in gray? What's so special about them? Talk to a partner first.
Because it multiply
Okay, back to me. Back to me. Let's see what you came up with.
You're multiplying by the same exact number, so that would be doubles.
Say it again.
Doubles.
Now say it.
Doubles.
These are the double multiplication facts. When you were in 1st grade, you learned about doubles addition.
Yeah.
This is doubles multiplication. I want to show you something really special about doubles. In multiplication, the doubles actually have a special name, right? That special name is they are called the squared numbers. All right, I want you to watch what happens. Here's 3 times 3. What does it do?
It's a square.
Now, if that repeats, it's a pattern. If it only works for 3, it's not a pattern. Let me get a different color. Give me another number that we think is a squared fact. What one?
It's 9 times 9.
Ooh, you picked a big one. Hope it works. Let me get myself ready. I gotta go all the way over here to the 9. I have to come all the way down to the 9. And then we'll finish this shape and we'll see if it makes a giant square.
Yeah, it does.
Well, let's check. Let's count how many numbers are across. Ready?
1, 2, 3, 4, 5, 6, 7, 8, 9.
So there's 9 numbers across. How many have to be up and down?
9.
If it's a square, there's going to be 9 numbers. Let's test.
1, 2, 3, 4, 5, 6, 7, 8, 9.
Oh. So somebody tell me again what's so special about the gray numbers? What's so special about them? You know what? I think you all know. Just tell me. Go.
Squares.
Look at the things I put in yellow. And I want you to tell me what's so special about those. This might take a little while.
That's exactly.
Are you picturing this?
Yeah. So it's like when you fold it, it'll still be the same.
When you fold it, it's going to be look, here's the 12.
It's literally just a mirror.
It's like a mirror.
Yes.
This gray line acts like a mirror. That's a great way to explain it. Here's the 12 on the other side of the mirror. Here's the 10 right above it. Oh, look at that. Does it keep going? This is a 6.
Yes.
What should I find at the other end?
6.
Here's why this is so important. This is the last thing I'm going to give you. You guys are learning your multiplication facts, right? Super important that you learn to know them just in your head. But if you learn the ones that are in yellow, you do not have to learn any of the ones in white. If you learn these, what do you know about over here?
It'll be the same.
It's the same. So someone already talked about it, that this 5 times 2, what's this one?
It's also 5.
5 times 2 and 2 times 5, do they have different solutions?
No.
Same solution. So when you start practicing your multiplication facts, if you will learn, what's the gray ones called again?
Square.
If you will learn the squares plus the yellow ones, you know all of them. You don't have to learn any of the white ones. Just learn the yellow ones.
Like if you see on like the tops and the sides, it counts by itself. So if you look at the 2s, it goes 2, 4, 6, 8, 10, 12.
Here?
And if you look at the 9s, it's counting by 9.
Oh, what's that called?
Skip 9s.
Okay, so she's noticing here that as we go down any column, this is the 2 column, so what would it skip count by?
2.
What's this column?
6.
What would we predict its skip counts by?
6.
Does it?
Yes.
What would be the next number then?
66.
Did it repeat itself?
Yeah.
Was it predictable?
Yes.
You found a pattern. I love it. All right, another pattern. Go. What's a pattern that you've seen?
So going like across, it starts by 1 and then it goes 1, 4, 9 by 3.
So 1 plus 3 is 4.
Yeah.
What's 4 plus 3?
9.
Let's try it. See if it works. Put 4 in your head. Add 3 more on. 4. Is it 9?
No, 7.
Oh. So maybe that's not the pattern.
I know.
There is a pattern there. I can't wait for you to find it. You found it?
It goes odd, even, odd, even.
Where?
Right there on the diagonal.
On the diagonal?
Yep.
Let's check that.
1's odd.
Is 1 odd?
Yes. 4 is even. 9's odd. Even.
Odd, even.
Oh, this is a new one that I have not noticed before. I wonder why it does that. That's interesting.
And then
All right, take a look at the poster. I want to stick with this idea because this is what I'm so excited about now. Are there any other odd and even patterns in this chart? In addition to this one? Besides that one, do you see more? Here's what I want you to do. Talk with people around you to see if you guys can figure out another odd even pattern. What's another odd pattern or even pattern? All right, what do you got?
all of the odd numbers go odd, even, odd, even.
So you mean 1, 3, 5, 7, 9?
Yeah.
What do you mean they go odd, even, odd, even?
Like when they like going down, odd, even, odd.
Oh, let's test this theory. She's claiming that if it's an odd number, 1, 3, 5, 7, 9, that when we go down, you said it's going to have what kind of pattern? It's going to have an odd and then an even pattern. Let's test it.
I agree.
Me too.
Say odd or even.
Odd, even, odd, even, odd, even, odd, even, odd, even.
What would that be?
Odd.
Oh, sounds predictable. I love it. We only did one though. We got to test someplace else to make sure that what you're saying is accurate. Let's do 7 row. Ready?
Odd, even, odd, even, odd, even, odd,
What?
even, odd, even, odd, even, odd.
That's a good one.
Odd, even,
All right, stop. It is a good rhyme. All right, I am liking that one. So somebody summarize that back to me. What was the first opening statement? What did she set out to prove? She said what? Repeat what you said.
All of the odd numbers, they're odd, even going down.
Go.
They're odd. All the odd numbers are going odd, even down.
Have a pattern of odd, even, down. What about the even numbers? Look at the even numbers. Do they have the same pattern?
No.
Oh, talk with your partner. Is there a pattern? Talk with your partner. You got an idea? Go. You think it will always be even? Let's test. 6, is 6 even?
Yes.
Is 8 even?
Yes.
Let's check it. 6, 8.
Even.
Is it even?
Even.
How about if I gave you 24? Is that even? Is 10 even? So they're both even? What will the solution be? Even or odd?
Even.
Does anybody know the solution to this one? Oh, you do? Just tell me it then.
240.
Is 240
Even.
even or odd?
Even.
All right, let's test this again. Wait. Is 9 even or odd?
Odd.
All right, get your thinking brains here. I'm going to multiply it against an even. Talk to somebody around you about, is the result even or odd?
It's gonna be odd. 90 is even. 90 is even. It's 90. It's gonna be odd. How's it even? It's even.
I heard some really good words from you. Can you put them into the room, what you said?
So 9 times 10 equals 90. But
Okay.
if you divide 90 by 2, it equals 45. So then, and 45 plus 45 equals 90.
So you're going to break this up into 2 groups of 45?
Yeah.
And that's what defines whether something's even. Can I put it into equal groups? So I can put 45 in one group and 45 in the other group. So is 90 even or odd?
Even.
All right, so this is going to put something new into our rule book. You with me? Before we were talking about if you multiply against 2 even numbers, it's always even. But this isn't 2 even numbers.
It's 1.
Yeah, there's 1 odd and 1 even. Can you look at the chart and decide, is there a pattern when there's 1 odd and 1 even? Is there a pattern? That means it has to repeat and it has to be predictable.